Hello everyone, in today's video we are going to see about theories of the corrosion. So this theories of corrosion will include dry corrosion or chemical corrosion. So this type of corrosion occurs mainly through the direct chemical action of the atmospheric gases. So whenever the metal directly comes in contact with these gases like oxygen, halogens, H2S, SO2, N2 or anhydrous inorganic liquid with the metal surface. That means whenever the metal comes into contact with all these gases, this dry corrosion will occur. We can also call it as chemical corrosion. Okay, in this dry corrosion we have three types. So that means a metal, how can it undergo the process of corrosion? That means in presence of these oxygens only we will have different states, like one will be solid state, one will be liquid state, and the other one will be the chemical state or something else. So we have different types. Okay, this main principle of this dry corrosion or chemical corrosion is when a metal comes into contact with these gases, a chemical reaction, direct chemical reaction will take place, so which will undergo the corrosion process. So this chemical reaction or these substances can be oxidation corrosion or corrosion due to other gases, liquid metal corrosion. So these are the three types of the chemical corrosion. So this is the main definition, and these are subtypes of this dry corrosion or the chemical corrosion. So we'll see what is oxidation corrosion in this video itself. So this is carried out by the direct action of oxygen in the low or high temperature on the metals in absence of moisture. So oxidation corrosion is only occurred in absence of the moisture. So there should be no water content, and the complete metal should be directly exposed to only oxygen. Okay, at what temperatures? It can be at low temperatures or it can be at the high temperature. So the metal should have only direct contact with the oxygen and no moisture or water. Moisture is nothing but humidity, and which consists of again water. So there should not be any water content. Okay, it should only have the oxygen. And we'll see now alkali metals and alkaline earth metals. So these easily get oxidized at the low temperatures. So these metals are like whenever oxygen, that means at least some amount of oxygen, if it comes into contact, then it will easily get oxidized and will easily get the corroded. So these are the reactions, and this is oxidation and this is reaction, and this is the overall metal oxide. So what is corrosion? It will form the oxides, sulfates, carbonates, and etc. Alright, we have discussed it in the previous video as well. So the corrosion is nothing but it's a combination of the oxides and all. Now what is the mechanism? We'll see. So what happens is, we'll just take one surface of the metal. Think this as a metal. Okay, this is a metal, and here are some oxygen, gases. Okay, metal is, and so whatever the formation, all these things will happen on the surface only. Now what is the mechanism? We'll see. So for what happens initially, the surface of the metal, that means this surface of the metal undergoes oxidation, and the resulting metal oxide scale forms a barrier which will restricts a further oxidation. That means first, when the metal comes into contact with the gases, okay, so what happens? It will form some layer. So think this shade as layer. Now whenever this layer is formed, this layer will protect the metal such that this metal will not be corroded again when it comes into contact with the gases again later on. So that means this layer will act as a protective layer for the next metal which is beneath the surface. Okay, that means the upper layer will protect the bottom layers. So it protect in the sense, it will not help the metal to undergo the corrosion process. It will help the metal just not to react with some other gases. So it will only react with this surface only. So that is what here, it will restricts further oxidation. Okay, now the extent of corrosion depends upon the nature of the metal oxide. So it will, what type of metal oxide it is. So based on that metal oxide only the corrosion will depend. That means if the metal oxide is stable, it will behave as a protective layer which will prevent the further corrosion. So that means whatever the metal oxide formed when it is reacted with the gases, if it is stable, then it will make sure that this metal will not undergo corrosion. Okay, it will not undergo further corrosion. No, okay, no corrosion. If the metal is unstable, if the metal is unstable, or the metal oxide which is formed is unstable, then it will definitely allow the complete metal to corrode. This is if metal oxide. Okay, this is metal oxide and this is corrosion. So if metal oxide is stable, it will make sure that the metal will not undergo the corrosion process. If the metal oxide is unstable, it will make sure that the corrosion will happen. Okay, and for these stable things, we can take examples as aluminium, lead and copper and chromium. Okay, and for these unstable metals, we can take in as gold, silver. This is gold, this is silver, platinum. So this will not undergo corrosion or oxidation, further corrosion. So if it is unstable, means it will just form like whatever I explained here. It will form a thick layer on the surface of the metal, and it will make sure that only that surface will act as a protective layer for the rest of the metal. And this is what mechanism of this oxidation corrosion. Also there is one more point in this. So if the metal oxide is volatile, that means whatever the formed metal oxide is evaporated easily, then that oxide layer which is evaporated after the formation, so the complete metal will not be evaporated, so it will leave some of the metal oxides on the surface of the layer. So this again will expose it to further attack. Again that metal will evaporate, again this complete corrosion will happen. So in that way, complete metal, whatever the surface and from the top to bottom, complete metal will get evaporated and it will get continuous corrosion only. That means what I am telling is, for example, this is the metal. Okay, on the top layer it has formed metal oxide. So okay, this metal is evaporative metal. So when it evaporates, the complete layer will not get evaporated, so it will leave some parts of the metal oxide there. So what happens when the one layer of the metal oxide is evaporated, whatever the remaining metal oxide, it will again undergo the reaction with the gases. So after that, the other layer will go, so it will leave again traces, again the other layer will go. So in such way, the complete metal will get the corrosion. And now we'll see corrosion due to other gases. So corrosion due to other gases means this type of corrosion will occur due to gases like SO2, CO2, Cl2, H2S, F2. So in this corrosion, what happens is the extent of the corrosive effect, it will depends upon the chemical affinity, so between the metals and the gases which are involved. So how severely the corrosion will occur, so it all depends upon the metal and the type of the gases which are involved in the particular temperature. So and this degree of attack, that means how severely the attack or corrosion is happening, it depends upon the formation of the protective film on the metal surface. So we have discussed this protective, what is protective layer is made up of. It is made up of metal oxides, and the mechanism I have explained you. So based on that only, the next layers of the corrosion will be depending. So for this corrosion due to other gases, if the volume of the film, that means if the volume of the protective layer is more than the underlying material, it is strongly non-porous, so it will not allow any corrosive gases. That means if you take metal, okay, this as a metal, so up to here the metal is formed, okay, up to here. So this complete is protective layer, okay, metal oxide. Okay, so the here what happened, the metal oxide is more than the actual metal. So what happens, since this layer, protective layer is more, it will not allow this metal to get corrosion. So this acts as a protective layer. It will make sure that it will not react, this metal will not react with the gases, other gases. Okay, if the volume is less, that means if the protective layer is thin and the actual metal is more, then it will not guarantee that the corrosion process will not happen, because the protective layer is very thin, so it can easily get uh, go away when the gases with a high concentration comes into contact with this metal. So it depends upon the complete metal and the film layer and the atmospheric gases. And the other type of corrosion is liquid metal corrosion. So in this liquid metal corrosion, it is mainly due to the chemical action of the flowing liquid metal. So when the metals are melted at a high temperature, they just convert from the solid to the liquid state, and from this liquid state, so because of that temperature and because of the liquid state and because of the gases that are present in that particular area, so it will easily get contact with those gases and it will form again corrosion. So this is due to the liquidity of the metal. Since the metal is in the liquid state and it is at a high temperature, and because of the gases present in its surroundings, it can easily get or it can easily undergo the corrosion process. So it completely depends upon the metal. So what the complete corrosion process is, the complete corrosion process depends upon the type of metal and the atmospheric conditions and the type of gases involved. So based on these three only, we can say that particular metal is getting or undergoing the corrosion process, or it has undergone the corrosion process, or if it comes into contact with any other gases, will it undergo any corrosion process. So all these things will be defined, or it can be known from only these three things. Okay, thank you.